All right. Hi, everybody. I'm Dan Polsky, co-director of HEADS with Jennifer Wolf, and we're here to welcome Michael Darden, who's an associate professor at the Carey Business School, fellow at NBER, co-editor at Journal of Human Resources. His research is in health economics and health econometrics. He's a tremendous colleague, and we're really excited about the work he's been doing related to cognition, and he's going to present the work he's been doing on an economic approach to mental health and cognitive ability in the elderly that we were fortunate enough to be able to support through HEADS. So with that, I'm going to turn it over to you, Michael. And as usual, you can I can help monitor the chat. Sometimes it's hard to talk and do the chat at the same time, but you can direct people otherwise. But knowing you, I know you will welcome feedback along the way with any interruption as we go along. But you can correct me if you'd like to handle this otherwise. So, but I'll turn it over to you.
Great. Thanks so much, Dan. And thanks to everybody at HEADS for the support for this work. And especially to those of you in the audience who've seen this once before in the Econ Brown Bag at Carey. So I hopefully will have made some progress since then. Yeah, so this is cognitive decline and dynamic selection. It's something I've been working on for a little while with NHATS data, really exciting data resource, especially for an economist to be using a new panel is just great. I'm going to motivate the work. Hopefully, let's see. There we go. Okay, I'm going to motivate the work with a little bit of stuff that we did earlier in the year that was published in the Journal of Risk and Uncertainty, thinking about the age profile of medical care expenditures in the elderly. And so what you're seeing here is a picture of Medicare claims data over the age profile, where we had a really cool linkage between Medicare claims and the National Health Interview Survey. So what you should imagine with the data that we were using is you had a longitudinal survey or longitudinal claims information on individuals merged with a cross-sectional survey that had really rich kind of health behavior, health information. And so I've got the age profile here over the claims age, and I've got 3 lines. So the red line are those individuals who took the National Health Interview Survey when they were age 66. The green line is when they took it at age 72, and 78 is the blue line. So, if you took the National Health Interview Survey at age 66, we were able to follow you forwards prospectively in the claims information for up to 20 years. If you took it at age 72, we were able to follow you retrospectively back to age 66, 65 in the claims data, and prospectively out several years. And then same for 78. And so what I want to draw your attention to in this picture, and I think motivates what I'm going to be talking about today, is the level difference between the lines at a given age. So if you look at, for example, claims age 69 here in the graph, you can see that there's a clear level difference between those who took the National Health Interview Survey at 66, 72, and 78. And the real difference, all of these people are 69 years old at this vertical line here. The real difference between the two is that we know that the individuals in the green and the blue lived onwards in the survey, whereas we don't know that about the red line. All we know in the red line is that they took the National Health Interview Survey at 66, and as the age profile went on, the composition of this line is changing because of selective mortality. So some people are leaving the red line through selective mortality. And what I think is really interesting here is that you see these lines converging. So after we condition on being alive, the green line is below the red line, but after that age, they converge. And the same with the 78 line. So what I'm going to study in this in this research agenda is this notion of dynamic selection. So non-random mortality and or sample attrition that changes the composition of a sample over time. And so this is inherently, a problem when you think about the age profile of health, because as people age, some people are dropping out through selection. So the goals of this work, the research agenda, I want to use economic theory, and theory here provides a really nice framework in the Grossman model to build a general kind of empirical model of health over the age profile that accounts for this selection and that accommodates different types of health and that captures both endogenous investments in health and exogenous characteristics. And I think of relevance for this group today, I'm going to apply the model to cognitive decline. And I'm going to do that using really exciting data from NHATS and also the Health and Retirement Survey. So I want to talk a little bit about why I think cognition, cognitive health, cognitive decline, dementia, Alzheimer's are a really good application of this more general model. And that's because the age profile of cognitive health and cognitive decline is one of the kind of the central empirical objects of interest in this literature. And it relates nicely to a seminal theory of determination of Alzheimer's and dementia, which is cognitive reserve theory from Stern. This is a summary article that he wrote in 2012. But cognitive reserve theory is this idea that through kind of endogenous actions and investments, like seeking out education or engaging in cognitively, stimulating activities, individuals, build resiliency in the brain against neuropathology, and that resiliency explains heterogeneity in kind of clinical outcomes. So this picture is from Stern 2012. Where you've got the cognitive test score on the vertical axis, and you've got neuropathology on the x-axis. So at low levels of neuropathology, there's a level difference between high reserve and low reserve individuals. And in the epidemiological literature here, high reserve and low reserve, it's usually proxied by highly educated versus lower levels of education, or people, again, who engage in kind of activities that you think would be cognitively stimulating, have occupations that are more cognitively intensive. So there's definitely a level difference in the theory between high reserve and low reserve individuals at low levels of neuropathology. But then as the pathology increases, you start to see a decline in the low reserve individuals in test scores earlier than the high reserve individuals. So this line starts to fall earlier for the low reserve individuals than the high reserve individuals. And then importantly, the slope of the decline for low reserve individuals is flatter than the slope for the high reserve individuals. And the theory there is that, at some level of neuropathology, it doesn't really matter how much resiliency you have in the brain. And so because reserve delays the onset of the decline, the slope is steeper. So then when we observe people at the kind of Alzheimer's diagnosis, these low reserve individuals will have lower levels of pathology than the high reserve people. So I thought, this is a great example where if you think that education proxies for reserve, and you think, well, in the literature, we know that people of different socioeconomic classes, statuses, and different levels of education experience differences in longevity, then you could very well see composition changes in these groups over time over the age profile. And so, what I'm going to try to bring to this literature is to say, do we really understand the age profiles of these declines? And I'm going to use this kind of Grossman framework to think about the cognitive decline age profiles in education, but I'm also going to look at race and smoking status. And so just as an example, if we think that longevity differences exist by education, then dynamic selection has the potential to bias the age profile of cognitive decline by education. And it could also create level differences. And then more generally, I think the model is actually going to be really helpful in thinking about how we might expect rates of dementia and Alzheimer's to change when kind of macro level like expected longevity changes. So recently, we've actually seen longevity in the United States decline mainly because of the opioid crisis and COVID. If we see that rates of dementia and Alzheimer's are actually going down, it might not be that we're making progress on those things. It might just be that we're selecting out a bunch of people that would have eventually generated the diagnoses that we've seen. So, I think the model is helpful in informing that kind of more macro level discussion. So here's just the rates of cognitive decline in the NHATS, the National Health and Aging Trend Study. I am using a measure of cognitive health of word recall, and I'll define it more clearly later. But it's just word recall. And then we've got age, and I broke it out by several different characteristics here. So the black line is overall. The blue line, there's a pretty clear level difference between for college graduates. And then the green line and the red line are for Blacks and for smokers. And those are lower, but not necessarily parallel. Here's what it looks like in the HRS. So in the HRS, you get better coverage of younger ages. In the NHATS, you get better coverage of older ages. So I'm going to use both data sets. And here you see very clearly parallel kind of trajectories over time in word recall. There's also, I think, some evidence in the data of some dynamic selection. So in this picture, I just condition on different maximum ages at which we observe a person. And you can see these kind of level differences between the groups. So people who we observe to be at least 96 years old have higher rates of cognitive health at age 90 than people who we observe at 90. So, some evidence that dynamic selection might be at play here. You see a similar kind of story with the HRS.
So can I interrupt here? A couple of people are putting, there's a little chat in the chat. Then Quincy, maybe you could bring that, since I'm more comfortable interrupting Michael, share with the group if you have a chance to unmute the question.
Yeah, sorry. So fascinating. So I didn't mean to interrupt. But so one thing I was just thinking about was just the presence of different biases in different cognitive assessments and tests. So we know that, kind of differences and kind of neuropathology tracks to like changes over time. So some groups of people may perform better or worse on some of these cognitive tests, and it does relate to education because of the items that are being used on each of the tests. So I'm just trying to figure out how that factors into this model here in terms of,
Yeah. So, I mean, I think, so I don't have a great answer. I mean, I think that is a good point. I mean, I think the more general problem here is that any measure that you use of cognitive health is going to have significant measurement error. And so, what I'm doing in this paper is I'm sticking with cognitive word recall scores simply for its simplicity. But I think definitely and I'm going to talk about this literature in a moment, but like in the cognitive skill formation literature, they take these measurement issues much more seriously. And I could definitely borrow from those methods to try to improve this. So I think for the moment, I'm going to ignore that.
Also, just want to mention, Michael has given the okay to ask questions during his presentation. So if anyone has questions that they want to ask, or you feel free to raise your hand or leave them in the chat or just, come off screen or come off mute.
Yeah, thanks. Yeah. Feel free to interrupt. So just some preliminary results. I'll talk about the method that I'm going to use in a minute, but if you just do a cross-sectional comparison between college-educated individuals and those that don't have a college education in the data, you're seeing that these word recall scores, there's the gap between college and non-college educated individuals in the cross-section is like 8.2 to 8.6%. But when I simulate my model, I'm actually finding a significantly larger difference between 12 and 17%. And importantly, for the cognitive reserve theory, I'm finding that these profiles of the age profiles are parallel after age 72, but before there's a significant widening, which is kind of counter to the cognitive reserve theory. And I'd love to get people's thoughts on alternative theories that might explain that. I find something similar with respect to the white-black gap in the word recall scores. So the cross-sectional comparison, 7 to 8%. In the model, it's 13 to 18% differences. So these gaps are much larger. In both of these, the theory is that we think that relatively low educated individuals or African Americans exhibit higher rates of excess mortality. And those people who are leaving because of mortality have relatively low cognitive health or cognitive scores. And so when you see that, the remaining low educated individuals or African Americans are relatively higher scoring on the word recall scores than the overall samples. And so that narrows the gap in the cross section, but in the model, I'm allowing for that, and it shows a wider gap.
Hey, Michael?
Yeah.
Is it possible that folks leave just because they're not being called back because of cognitive decline? So they may still be alive, but there's some selection into getting essentially attrited by the survey operators.
Yeah, I'm going to show attrition's a really big part of this, and so I'm going to model that as well.
Okay.
Yeah, for sure. And I think, and the attrition, that's a great question, because the attrition problem is going to occur. I mean, that's where we can really connect to the economics of education literature. So Heckman has all these papers going back a long time thinking about the fact that if you want to understand what's the effect of parental characteristics on the probability that a kid transitions to the next grade, well, as you get to higher and higher grades, you're getting a selected sample of individuals. And so, not surprisingly, they find that parental characteristics matter less for transitions into college, because you've got a selected group of people at that point, and that attrition issue is more general than just the mortality one. You wouldn't see much of a mortality effect for the young kids. Small effects on smoking, not significantly different than previously thought, and a relatively parallel age profile. So I'm not going to spend as much time on that. So just to connect to the literature a little bit, I've talked about the cognitive decline and cognitive reserve literatures. This has been a big, this is what I've been working on a lot in the last month or so, to try to connect it better to the cognition literature. It also connects to 3 areas in economics that I'm excited about. There's a long labor economics literature that mentioned, as well as an econometric literature on incidental truncation. These papers use inverse probability weights, or that's where that literature has kind of settled. I'm going to argue that the problem with inverse probability weights is that it does not account for the mechanism of selection. And in this case, I'm going to call that kind of general health, and I'll talk about that. It connects to the health economics literature, long literature on thinking about to what extent does education or race or other kind of characteristics predict mortality. And importantly, that literature focuses on mortality and not health, because of this selection problem. So, being able to study the effect of education on health has actually been quite difficult. And most of the literature has kind of worked around that by saying, let's just study mortality. And then finally, skilled formation, there's a long literature here thinking about these measurement problems. So test scores are biased, as Quincy mentioned, and create bias and create measurement error. And so they think about factor models that allow for you to kind of capture that measurement error. I'm not going to actually do that here, but it's a natural next step for the research agenda. Okay, so I just do a quick overview of the model and the empirical model. This is going to be quick, and then I'll get to the data. The basic idea that I have in mind here is one in which you have the value of being in a certain health state at age A is the maximum of the contemporaneous utility, which is a function of general consumption, health investments like smoking or education, and then shifted by cognitive health and general health. So the key part of this model that's different than if you're familiar with the Grossman model is that I'm going to partition health here into kind of overall general health H and cognitive health C. I'm doing that again because I'm interested in how different aspects of a person affect C. But the important thing to capture in a model like this is the fact that what drives mortality is actually H. And so the correlation between H and C is going to be a very important correlation for me. So we've got a kind of contemporaneous utility plus the present discounted value of future utility, but you have to survive to the next age to be able to enjoy that. And so that's where the H is going to be really important. What this model produces, when you think about some constraints, so you've got how health evolves and how cognitive health evolves, what it produces, though, is something that's very empirically tractable. And that is that if you make the assumption that the correlation between H and C is bivariate normal, you get this really nice equation. So I'm going to I'll spend more time on this than the last one. The left side of this equation is the difference in means of cognitive health, so the expected value of cognitive health at age A+1, conditional on living to age A+1, for people who make some investment I, minus the average cognitive health of people who survive to the next age for the people who did not make that investment I. So this could be a difference in education, it could be a difference in smoking, but this is what you observe in the data is, you can say, what is the word recall score for highly educated people? And what is the average recall score for lower educated people? What the theory produces is actually really nice, though, for those who are familiar with these kind of selection models, is the average treatment effect on the treated, which is actually what we want. How does the investment, education, or smoking, or whatever, how does that affect cognitive health? And this dynamic selection effect, which is important because it says that the average treatment effect on the treated is not the difference in means. And so what you have to take into account is this dynamic selection effect, and we can think about this dynamic selection effect in the data. So let me talk about what that dynamic selection effect is. It has three main components. Rho is the correlation between general health and cognitive health. Sigma is the standard deviation of cognitive health, and then alpha and gamma here tell us how much does this particular characteristic, education or smoking or whatever it may be, how much does that predict longevity differences, or the probability that somebody transitions out of the sample. There could be attrition as well, but how much does that particular characteristic, how much does it change the longevity profile, the probability that I would observe someone? And so we can look at these things in data, and we can then try to get a sense of how bad this dynamic selection effect would be. But the general intuition is that if you think that something like education is protective against longevity, then that's going to create a situation in which this dynamic selection effect biases the difference in means. So that's what I'm going to look at empirically. And the empirical model is kind of a quasi approach at trying to capture these dynamics. So what I'm going to propose to do is estimate a system of equations that would come out of a theoretical model like that. So you've got general health capital H, you've got health investment I, again, that's going to be like smoking, cognitive health C, and then sample exit. So Lawrence, you can see I'm now calling this sample exit, which is trying to capture the fact that we're not just talking about mortality, but also attrition. And so I'm going to estimate these models jointly while accounting for correlation in the error structures. Okay, so each one is a dynamic equation. So health is a function of health, the lagged health, investment is a function of lagged investment, cognitive health capital is a function of lagged cognitive health capital, and all of these things predict whether or not you die or attrit from the sample. So it's a system of equations, and I'm going to allow for like a semi-parametric distribution or treatment of the error structure. So I'm going to allow there to be correlation between the unobservables that affect sample exit and cognitive health. And so I'll talk about that. Any questions about this approach? Okay, so I'm going to characterize the joint distribution of these error terms for investment, for health, for cognitive health, and sample exit in a semi-parametric way. So I'm going to decompose the error term into a permanent component and a transitory component. And I'm going to allow that the permanent component is correlated across the error terms. So, without looking at the slide or the math, just think about this as there are types of individuals that have high cognitive health and are unlikely to be smokers, right? So it might be picking up the fact that some people, have better information, or they are more risk averse, or they have different levels of time preference. So I'm allowing for that correlation. And then I'm going to solve the kind of classic initial conditions problem by saying the initial conditions of cognitive health and general health and investment affect the probability of being each one of these types. So I know I'm kind of flying through this part, but I'm going to, I think it's much easier to see when you just look at pictures. So I'm going to try to get to that part. The model summary takes a Grossman model. It partitions health into health, like overall health, and cognitive health. Solution to that model yields demand and outcome equations. And those outcome and demand equations I'm going to estimate jointly with a kind of maximum, full information maximum likelihood. And then I'm going to simulate the empirical model to try to get some empirical results, to try to demonstrate the importance of this selection. Okay, so let me talk about the data. National Health and Aging Trend Study, just a really, really nice recent nationally representative sample of seniors. Probably don't have to go through too much of this for this crowd. Started in 2011, annual interviews, and there's just really rich information on health, healthcare, and socioeconomics. I have access to the geocoded data, and so I am going to use some geocoded information for exclusion restrictions here. But the mean age at the initial wave is 76, so that's relatively old. And so what we're going to do, that's why I'm going to also bring in the HRS to try to get coverage of younger ages. National Health and Retirement Survey, here we're going back to 1992. I'm going to start in 1996 just because of the way that the cognitive recall, the recall questions were asked. But here I'm using biennial interviews, and so I've got a longer period of time to look at these individuals. I'm going to use up to 11 waves. Mean age in 1996 was 66. Okay, measurement. So cognitive health, in this case, C, is going to be measured as the sum of the immediate and delayed word recall. So yeah, I'm taking the immediate 10 questions. How many words did the person recall in the immediate question set? And then adding the 5-minute delayed recall, so that the measure that I'm going to use is relatively continuous between 0 and 20. Again, not perfect, definitely prone to measurement error here. The goal is simply just the goal of the paper is to show results about dynamic selection. But I do agree with the comment that, we should incorporate more, we should be, more kind of inventive, innovative with respect to other measures. H is going to be general health. And here I'm going to measure that. Kind of a standard count variable that you'll see in the EPI literature of the kind of sum of chronic conditions up to period T. So again, also not a perfect measure of general health. This is another reason why the econ literature focuses on mortality, because measuring health is actually really hard in an aggregate index kind of way. So I'm going to simply add the number of conditions that a person has up to a given interview. Some sample statistics. So this is going to be information from NHATS and from HRS at the initial wave. So again, for NHATS, this is 2011, and for HRS, it's 1996. The word recall score, you'll see, again, out of 20 possible words recalled, overall it's 8.1 for the NHATS group in 2011. It's 10.1 for the HRS. You'll see that it tracks fairly consistently across the two surveys. For college-educated individuals, it's about 1.5 points higher, or a word and a half higher. For Black individuals, it's about a word lower. And for smokers, it's a little bit higher, if anything, which may reflect, age differences. These are totally unconditional. And then in terms of smoking, so college education, excuse me, I should go to that. 22.5% of the overall NHAT sample have a college education. 16.8 have a college education in the HRS. Here are the race breakdowns. And then smoking, 8.2% are current smokers in NHATS at the initial wave, 17% in the HRS. I'm looking at 5,750 people in the NHATS. I'm looking at 11,000 roughly people in the HRS. Okay, so then the observed to die, observed to attrit. So overall, I'm going to see more people attriting, to Lauren's point. 43% of the sample at some point will leave through attrition in the NHATS. That's only 15% in HRS. 23% of the observations I will observe to die in the NHATS, and in the HRS, it's 51%. Again, the HRS is going to be over 20 years. So that's why there's that difference. Okay. Excuse me. Okay, so remember in the theory that the dynamic selection effect said it's going to be non-zero if the correlation between general health and cognitive health was non-zero, and if there was an effect of the investment or the kind of characteristic of interest, education, smoking, race, on longevity or sample observation. So I can look at that in the data. So here is the number of the word recall score by the number of chronic conditions. And you see a pretty clear, statistically significant gradient here. People with more chronic health conditions have lower word recall scores in the NHATs. So it checks that box. So it says, yes, okay, there is going to be a correlation between general health and cognitive health. You see a perhaps more striking gradient in the HRS data. Okay, so that rho is probably not zero. And then the other piece was there some kind of longevity difference? Okay, and so this is the Kaplan-Meier survival, where survival here is just being observed in the sample. And you do see that there's a gap between college graduates and less than college graduates in the data in NHATs. And again, don't take the level of this too seriously, right? Because like we're conditioning on living to age 76 already on average. So what's important here is that there's a gap between the two lines. Similar from rate.
Could I interrupt with a question?
Sure, yeah.
When you were talking about the theory and the model, it seemed to me that you were using investments in health as an important, what do you call it, control variable, I guess, or decision variable to drive the dynamics of this.
Yeah.
I'm a little concerned by the fact that education is basically completed early in life, and you're looking at people late in life. That's
Right.
less true of smoking. I don't think there's a lot of investment-related changes in smoking behavior. But so what I'm worried about is that you've got some potentially serious omitted variable issues with things like late life investments, like exercise, which is in those data sets. And I'm wondering why you're basically creating an omitted variable problem.
Yeah, okay, so I should be clear about what I'm assuming. First of all, I am assuming that conditional on the stuff that I do have in the model and the unobserved heterogeneity, that race and education are totally exogenous. Okay, so yeah, those are clearly going to be predetermined for our, when they get to NHATs and HRS, their early life or just kind of innate characteristics of individuals. I am going to assume that they're exogenous here, conditional on this unobserved heterogeneity that says there are types of people that kind of engage in smoking or have lower health or are more likely to die, independent of everything else. So those, I mean, that's just going to be a maintained assumption. So the problem there, you'd be concerned that something like highly educated people are also more likely to be physically active, and so therefore, and I'm not going to talk about that in this paper, because the goal is to show the selection effect under the assumption of exogeneity. So the nice thing about the model is that if you care about the causal effect of education, you can build in exclusion restrictions or model it directly. In the case of smoking, it's different because, as you say, smoking is now going to be changing during my sample period. And in this case, I mean, almost no one is starting smoking here. This is cessation from smoking that's occurring over time. And here I am going to have exclusion restrictions where I've got kind of local area tobacco control laws that affect the probability of smoking, but that don't affect anything else in the model. So that's like a standard way of kind of handling it. It's not perfect, but there is trying to be some exogenous variation, local area taxes, local area indoor smoking laws that might encourage people to quit smoking, that would only affect anything else through its effects on smoking. So I thank you. I should have been more clear about all that. Okay, so big gaps between smokers and non-smokers and longevity, gaps in the survival in the HRS for college educated versus non-college educated, by race and by smoking. So these are just to show that, if you think that the dynamic selection effect is a function of these characteristics, the correlation between general health and cognitive health, and the extent to which these investments affect sample observation, then we've kind of got that in the data. Okay, so I'm going to compare my system estimator to OLS and to inverse probability weighting. So the idea here in the first column is to just say, let's just make a cross-sectional comparison between college-educated individuals and non-educated individuals, blacks and whites, and smokers and non-smokers, as it affects this word recall score. And so what I find in the OLS here, I'm just going to focus on NHATs just for this crowd, that there's about a 0.7 word gap between college-educated individuals and non-college-educated individuals in the data. There's about a 0.66 word gap between whites and blacks, and there's about a 0.16 word difference between current smokers and non-smokers. Okay, so inverse probability weighting, the next set of results. This is used in a lot of different literatures to handle what I'm calling dynamic selection. Other literatures called survivorship bias, but whatever it may be. Inverse probability weighting is the idea that you say, well, let's estimate the probability that somebody leaves the sample as a function of their observables, and then use that probit model to construct weights that we use to weight the kind of the outcome of interest in the main equation. So cognitive health on the characteristics, and it really doesn't make much difference in my case. So using the inverse probability weights doesn't change things very much. And so my critique of inverse probability weighting is that what it's not capturing is that rho term, which is the correlation between general health and cognitive health. It's not modeling the mechanism by which most people are leaving the sample. So it's either leaving the sample through death, which is clearly going to be affected by health, or attrition, which I would argue is also going to be affected by health. People get a health shock, they have a chronic condition of some kind, and then they're less likely to report to their NHATS interview. The final column here are my preferred estimates. I'm calling this discrete factor random effects. And they're considerably larger in magnitude, which is consistent with the theory. The theory says that these effects should be larger because when we don't account for exits from the sample, the people the people that we actually observe are relatively healthy in the groups of less educated Black and smoker. And you see the same pattern in the HRS. So let me just show you a couple of other some graphical results then to try to drive home this selection. This is a picture of my 5 unobserved types that are affecting each equation. So the idea was, again, that we're allowing for correlation in the unobservables in all of the equations in the system. And I broke that permanent component into 5 discrete types. And so what this shows is the simulated proportion of individuals in each type over the age profile. And what you see is that if you look at type 2, which are the red individuals, they start at age 66 at roughly 27% of the sample, but then over the age profile, their share of the sample drops considerably. So type 2 individuals are much more likely to attrit the sample, according to the estimates, and they have much lower cognitive scores. So this is the selection effect that I'm talking about. Who are the people who are dropping out of the sample? Well, they're the ones who have lower scores. And when you do that, when you get rid of a bunch of people that have lower scores, that's pushing averages up. So these are individuals who have lower scores and are much more likely to attrit. The black line, type 1 individuals, and especially type 1 individuals, are more likely to have higher scores. So they're contributing to a larger fraction of the sample over the age profile, which is generating the results, which is why I'm seeing these differences between the preferred estimator and the inverse probability weighting in OLS. Okay, so here's the simulation results. So this is just me looking at people who have a college education and then taking it away and seeing what happens. The black line is my preferred estimator, and the blue line is from OLS. So what does the age profile look like in OLS versus my preferred estimator? First of all, they're statistically different. So the confidence intervals are never overlap, and this is in the NHATS data. So you see about a one word difference between these two, and in the effect of education. And if anything, it's growing over time, the effect in the main estimator, whereas it's actually getting smaller and maybe even insignificant in the single equation estimator. Here's the effect of college education in the HRS sample. Again, it's nice in the HRS sample because we can look at younger ages, and you can see that in the late 50s and 60s, there's really no difference between these two types of estimators in their prediction of the effect of education on word recall scores, because the sample exits haven't really taken bite yet. It really only starts to emerge, the gap between the two, in the late 60s, where you start to see this selective mortality and attrition really becoming a problem. And importantly, if you just take the black line here, the effect of education on word recall scores is relatively small at young ages, and it grows over time, and it becomes relatively parallel or flat at older ages. So thinking back to the cognitive reserve theory, it's kind of the opposite here, where we're seeing that highly educated, there's a parallel difference between educated and non-educated individuals at older ages. Remember that it suggested that, the theory suggested that those lines should converge, but this is saying that those are relatively parallel. It's where the gap really emerges at younger ages before the selection takes effect.
So Michael?
Yeah.
The divergence at the younger ages, does that mean there's greater selectivity in the lower educated than in the college educated?
Yeah, so the story, you're right. So the story here is that when is there the selective exit by group? It's by, so when is it that the lower educated individuals are dropping out at a rate that affects the estimates? It's going to be at the younger ages.
But actually, I take that back. It should be the college educated, right? There's more selectivity. Otherwise, the gap wouldn't expand, right?
I don't understand.
So we have two groups, the college educated and the non-college educated, and we see this gap widening between the two.
Yeah.
And so if this is due to attrition, which is why your two curves diverge.
Yeah.
Which group shows greater attrition, right? Which group has the greater proportion of folks who have low word recall that drop out?
Yeah, so it's the lower educated, right? So the lower educated are dropping out at faster rates, at young ages.
Uh-huh.
And those are the individuals, and the people who are leaving have particularly low scores.
Yeah. Got it.
Yeah. And you actually see this trend occurring in other dimensions as well. So here's the effects. Here's the white-black gap. So this is I should have these the same direction. I'm sorry about that, but this is the black coefficient. So it's relative to white. So it's, in this case, it's negative. And you see that in the NHATS data, you're seeing this kind of, we don't have the younger ages in the NHATS data, but you are seeing that it becomes relatively parallel at older ages. And it's growing in absolute value at younger ages. You'll see it better here in the HRS. The white-black gap is growing as you have selective exits, and then it's relatively flat over time. And again, statistically different than the OLS estimator. And then in the smoking estimator, you see a kind of a similar pattern, but we don't have statistical significance because the effect of smoking generally on word recall scores is not large. And so, you're just, and furthermore, you see very few smokers in the 90s, so you're just getting these huge confidence bands. Similar with the HRS. Again, you're just seeing not like the selection effect is not enough to kind of separate these two lines. Okay, so just to recap then, finishing up here a few minutes early, hopefully, just some time for discussion afterwards. But education and race, I'm finding bigger gaps in word recall scores than previously thought, than in the literature, but also in just kind of cross-sectional comparisons within both data sets. Age profiles in both race and education are relatively parallel after the early 70s, but they grow the gap grows in the 50s and 60s. And small and insignificant differences in smoking as a result of smoking. So this is obviously preliminary, but I think what it suggests is that a divergence from the cognitive reserve prediction. And it also, I think, more generally says that these kind of selection effects can be really important if you're interested in the age profile of some health measure. It doesn't have to be cognitive health here at older ages. So I'm developing this general framework, and I'd like to think about ways to enrich it in the context of cognitive health, but also try to apply it to other dimensions of health. Particularly, I was thinking with respect to BMI and obesity, because of the really interesting age profile in BMI and obesity. So I'll stop there. I see there's another question in the chat. Maybe I can, let's see. If anybody wants to just go ahead and ask, please feel free to. Gail, I see you raised your hand.
Hi, this was a fascinating presentation. The only comment I have is when you refer to exogenous and endogenous variables. I probably didn't catch this, but what variables affect education? Because you said it's an exogenous variable, but I was trying to figure out when you said there are variations in level of education and they're exogenous. So what would affect education? So from an economic model standpoint, with things like, I'm assuming you mean things like SES, parents' education, social structural factors like racial segregation, because during the time that these population sample participants were given the survey, they had obviously lived at a different time period. So I'm assuming that when you talk about contextual factors and the understatement of key factors, you're actually assuming that for that exogenous variable, which is the independent variable, it has to be affected by something else. So there, it's just not, you know, these two population demographics are just intrinsically different. There is some underlying causal factor. And I know the literature is rich in talking about SES and social structural factors and things like that. So since your paper is trying to develop a contextual framework, are you willing to at least include some of those underlying precursors, since it is based on differences in population demographics?
Right. So, I mean, let me tell you what I'm assuming here. And then I totally agree with you that education is a very coarse proxy for a lot of stuff that's going on here, you know, especially in the kind of historical perspective of when these people would have been, you know, getting education or not. The assumption here is just to look at different. So I'm looking at different education groups because it's simple, and it's also what's used in the kind of cognitive reserve theory literature. You know, what is cognitive reserve? Well, you know, they don't know really either, right? So they're coming up with this kind of education classification. I agree with you that education is going to be a function of a whole host of other things. The model right now is not built to accommodate those things. The model is saying conditional on some unobserved characteristics that are kind of impermanent about a person. And the examples I gave were kind of like risk aversion or you know, you know, time preference. Conditional on those relatively permanent things, that I'm just going to treat it like an exogenous variable. So I agree that there's more that could be done there, but as it stands, I haven't modeled education. The other thing is that education, like you said, I mean, it's determined so long ago relative to this sample that it's you know, it's something I could look into. And one of the things that people have used there is like compulsory schooling laws. So like, you know, if you and I were born, you know, around a cutoff for an age group, right, and maybe one of us was forced to go to school for an extra 9 months because of a compulsory school law, and so people will use kind of exogenous variation in education driven by that. It's hard to do that in the context of these surveys, though, because you have relatively small samples.
So if I can ask one more question. So does your model say you get like one more word if you got a college degree, roughly, and that doesn't change?
After, yeah, so the age profile, sorry, I have the chat up, so I can't even see what I'm looking at. Yeah.
Right.
So, right. So it's like
1.5 words.
Right.
Is that a big deal or a small deal? I mean, you pay $40,000 for a college education, and then you get one more. So what I mean, and this can be done offline, but I'm just wondering what are the, you know, practical implications, or what does that predict, right? Does that mean you can, you know, figure out your required minimum distribution or not, or what does that, what's the practical import? And I hate to ask this question, but I always do.
And I hate to interrupt, but we are at the hour, so there'll be time to answer the question. But I just want to respect the time of this, you know, ending at 1, and you know, you can stay on. Hopefully, we had a chance to answer that question, and maybe a couple others. But a formal thank you to Michael for just, you know, an amazing work, and I think we're all really excited to see, you know, what comes next year. And thanks for being with us, and thank you for everyone and your comments, and we'll have a formal end, and hopefully have a chance to hear the answer to this question and maybe a couple others for those who stick around.
Thanks, everybody. Really appreciate the opportunity to present. Yeah, Lawrence, no, that's a great question. I mean, honestly, I don't really know. I think that's the next step, is kind of trying to use this to make some predictions about magnitude. You know, and you're the machine learning guy, so if you want to, that becomes a prediction problem to some extent, you know, right? But my main point here was to try to look at slope differences and level differences, and you know, I've kind of found that. I mean, I think the thing that I'll hang my hat on, though, is the fact that the cognitive reserve literature, the cognition literature, is obsessed with education differences, right? So and they're working on this kind of 0.5 notion. So I would imagine that 1.5 would really pique their interest. But yeah, I should know more about it.
I have a follow-up question for those that want to stick around. So I guess it's the implications for this work on, you know, general, you know, the literature that's out there, that kind of stylized facts that are out there around the impact of, you know, earlier behaviors on the probability of having you know, ending up with Alzheimer's disease.
Yeah.
Kind of this, how does survivor bias somehow, what can we learn about those stylized facts, or how should we adapt our thinking in the context of what you presented?
Yeah, no, it's a good question. Well, I mean, I think, the obvious first thing is just that these things may matter more. But I think that there's probably a competing risk story that I could tell here that would be kind of more illuminating, in the sense that, like, if you think about something like education affecting general health in some ways that we don't really understand, you know, that's going to imply that you live longer, but it's also, you know, so you know, in kind of the economic value sense, the economic value of an investment in health is both the quality of life while alive and the longevity effects. And the competing risk story here is that, you know, these kind of investments might affect both in a bigger way than thought. This would be saying that, you know, the quality of life, as measured by word recall scores, would be greater. But I don't know. I'm open to thoughts on that. Antonio, you got your hand up.
Yeah, thank you, Michael, for a very nice talk. You remember me, Tom Ross work on discrete factor, getting the weight of the.
Yeah.
But in any case, you don't think that you need to run these survival differences by gender? Like, I expect the healthier grandpa, and I expect males dying sooner. So what I do this is using non-parametric age and running by gender my scenes related to cognition and all of this. So, you know,
education, I mean, sorry, gender is in there. I'm controlling for it.
I know, but the production, the relationship between gender and, I mean, cognition and health will be different among female than male.
Are you suggesting that I run the model completely separately for the two
Yeah,
groups?
that's what I have seen. And
okay.
Anyway, I could be wrong, but
okay. That's a good point. I could do that.
I mean, maybe the gap will be different.
Yeah, I mean, yeah, no, we did that in the context of a smoking and longevity paper a while ago. We did it separately for men and women. I mean, I always like, especially with these panels, you know, the trade-off is that, do you really think that like every parameter should differ by gender? And if so, you know, if not, then, you know, you're wasting a lot of degrees of freedom by doing that.
Got it. Yeah.
But, you know, I totally agree that, you know, there's going to be a gender gradient here with respect to the exits that is important.
You didn't show the absolute levels of these trajectories, right? Just the relative.
Yeah.
So the deltas between, you know, these dimensions. So I guess I would be curious to see, you know, how fast does the word recall decline by age, if at all, right? It should, right? We would.
Yeah, I've got that. I do have that.
Oh, I see.
It's
Okay,
actually
early on.
It's actually at the beginning. Here.
Oh yeah, that's right. Got
Yeah.
it. Yeah.
Right.
Yeah. And I think that also would then, I think that might lend some perspective on these differentials, right? So you could say having a college degree is equivalent to being, I don't know, X years older, in how you lose those word recall values.
Right. I've read about the difference between biological and kind of what was the other one? Biological and cognitive age or something is different.
Right. Like your real cognitive age.
Right.
Well, maybe this is time for our second thank you to Michael. And that was terrific.
Thank you. Yeah. Thanks everybody for coming.